So there he comes. So this was actually the last lecture in this course, and I just want to give you a quick walkthrough what we have done over this spring semester. And first of all, a little bit why we do this quantitative big imaging. In principle, what we do have is experimental data, loads of it actually, and we have limited time, we have limited manpower, and of course we want to publish the results supported by some quantitative analysis. We want to make sure that it's reliable, repeatable, and for this we also want to have some automated workflows. And first of all, we need to understand these components: data creation, image processing and analysis methods, how to work with the data, some computer science and engineering, and finally also how to present the results to make sense and convince people that it's actually what we have done. And our workflow goes through that we need our images. We may look into some data sets, maybe not in the beginning, not even our own, but we needed to have some test data for our algorithms. Then data is rarely what we expect them to be, so we need to enhance the data, doing some filtering. And then we jumped over to segmenting the data, identifying regions of different kinds, which gives us the possibility to identify different objects and so on. And then we do some more advanced structural analysis, followed by uncertainties and statistics. Then we looked into two special cases, time series and bimodal. And today we looked into the computing part of the task. So in the image basics, I was talking about what is an image, pixel-based operations and the histogram. And then we looked into the data sets and the validation. First of all, using prepared data from other ones, also defining what is a good data set, looking into analysis validation workflow and the importance of having a ground truth and actually also a baseline algorithm should be added on that slide. And in the image enhancement, I started out telling that the word is not nice because we have noise and we want to reduce the noise. And but we can also use the filters to enhance different image features, looking at orientations, edges, etc. And again, looking into the performance analysis, at this time on the filters. The lecture 4 was about the basic segmentation. Started out actually with how images are formed, the whole creation process, and what is a change in contrast, does it mean, in particular for radiography, and how to apply thresholds, mainly using the histogram. Then we went into the methods how to automatically find the thresholds, unsupervised and supervised, depending on what kind of data you have available. So the unsupervised were histogram based and could also be clustering, whereas the supervised methods require some ground truth and need training phase and a prediction phase to work. And looking at the shape, we looked into component labeling, identify different items. So from the segmentation, we only got the black and white or few levels. And then we have shape properties and also looked into textures. So the patterns that you could be identifying different regions in images. The complex shape is, there I went into particle clouds, saying a distribution of particles, are they different from each other? And then segmentation of touching objects, because the first labeling we did couldn't handle the case when objects were touching each other. it labeled them as the same, and also going on to thin structures, mainly with the skeletons, which minimize the structure to a minimal morphological reproducible structure. Statistics is important throughout. We had so actually that is how we bring our conclusions from the data. And one thing important to start with is the uncertainties in our analysis, and then we went on to probability and some implications of statistic and analysis. And dynamic experiments was in principle taking everything into an application field. Things are not static, they move around, and there are different types of dynamic experiments which produces the need for time series analysis, where we want to do tracking and registration before we can do any conclusions. The multimodality, oops, that is too much. No, that's right. That's just many topics. That was last week, the recorded lecture, pre-recorded lecture, where I talked about multimodality imaging. So one modality may not be sufficient, and therefore we combine to get more information about your sample. Again, the registration is needed, and we need to fuse the data in a smart way. Plotting is needed in the end to convince people, so how to present the results in graphs. I also went into some software engineering. Important points were that unit testing can help you to be sure that your code is doing what it's supposed to. And repositories is really a good idea to work with. If you go really advanced, you can also go into continuous integration, which is barely visible on this slide. And then I came to today's lecture, which is about scaling up, where we talked about parallel processing, distributed computing, and DAGs. And the last part was the project, which some of you have started. And the idea with the project is that you can, in principle, get your hands dirty on some real data, feel what it is when things are not laid out in a nice way as in exercises, but you really have to be creative finding things. And there, the idea is that we have presentations on Thursday in 3 weeks. 3 weeks, yes. And well, I write here 10 minutes. Well, that depends on how many have done the project. And the idea is that you should present the problem, a solution, and some key findings from your project. I have provided a little list of some projects, and you're also welcome to come with your own ideas. Could be from your master or PhD project, if you like to do that. And well, project support, there are no more lectures. So if you are doing the project, you can contact me or Daniel. Making appointments, we are usually not in Zurich, so we have to do those consultations remotely. Myself, I'm in the week of 18th to 22nd. I'm on a business trip, so my response may be time shifted a bit, but I will try to reply anyway when I'm away. And well, that was the end of actually last lecture and the whole class, more or less, except for the project. So thank you.